Hi guys, today let us derive the input impedance relations. Now consider a circuit with voltage source Vs and current traveling through that is Is, and it be the R resistor, and the distance is L minus X, and X equal to 0 at the source end, and at the middle end X equal to Z, and at the load end X equal to L. Now let us look the definition. Input impedance is the impedance which is measured at the input terminals of a transmission line. That means input terminals means Vs and Is. Then the formula is Z input is equal to Vs by Is, where Vs means voltage source and Is means current source. They both are at input terminals. We know that basic transmission line equation is V equal to VR into cos HP into L minus X plus IR into Z naught sin HP into L minus X. Then for current, I equal to IR into cos HP into L minus X plus VR by Z naught into sin HP into L minus X. Now consider source end. At source end X equal to 0 and V equal to Vs and I equal to Is. Then by definition, Zin equal to Vs by Vn. Now Zin is equal to, let's divide this. Then we got this. Then multiply numerator and denominator with Z0 into Z0 by IR. Now we got Z0 by, now we'll get this equation. Now let's multiply numerator and denominator with Z0 by IR. Here IR will get cancelled and IR will get cancelled and Z0 will get cancelled. Then we know that ZR is equals to VR by IR. So VR by IR is equal to ZR. Z0 into ZR cos HPL plus Z0 into Z0 sin HPL divided by Z0 into cos HPL plus ZR into sin HPL. Now let common the cos HPL. Now cancelling it, then we get Z0 into ZR plus Z0 into tan HPL divided by ZR plus Z0 tan HPL. Now let us consider some conditions. Case 1. Open circuit lines. We know that for open circuit lines, ZR is equal to, ZR means characteristic impedance is equal to infinity and Zin is equal to ZOC. Then we substitute it in our input impedance equation. ZOC is equal to Z0 into ZR into 1 plus Z0 by ZR into tan HPL. Here we common ZR. Then we'll cancel the ZR. Then we'll get Z0 into, after us cancelling this, we'll get 1 by tan HPL. We know that 1 by tan is equal to cot. Then ZOC is equal to Z0 into cot HPL. Case 2. Short circuit lines. We know that for short circuit lines, ZR is equal to 0, Zin is equal to ZSC. Then we substitute this in input impedance equation. ZSC is equal to Z0 into tan HPL. Because ZR is equal to 0, it will become 0. Then Z0 into tan HPL by, we know ZR is equal to 0. 0 into anything, 0. So Z0 into tan HPL by Z0. Z0 cancel, we'll get Z0 into tan HPL. Then third case, matched load. Matched load means when input impedance is equal to load impedance, then matched load will occur. Zin is equal to Z0 into Z0 plus Z0 into tan HPL divided by Z0 plus Z0 into tan HPL. Hey, I forgot to write H, okay. Then cancelling both, Zin equal to Z0. This is matched load condition. And the last case, lossless line. We know that for lossless line, P equal to alpha plus J beta. For lossless line, alpha is equal to 0. So we get P equal to, after substituting alpha value in this equation, we get P equal to J beta. So substitute this P equal to J beta in input impedance equation. We will get this one. We know that tan hat J beta L is equal to J tan beta L. Z in equal to Z naught into Z r plus Z naught into substituting in this place, this one will get Z naught into tan beta L plus by Z naught plus J into Z dot tan beta L. Thanks for watching our channel. Do subscribe for more.